Hi, this is Mrs. Lemke here with a lesson about binomial probability. So we are going to learn as our last two topics of the year, this topic, which is called binomial probability, and then our last topic will be on normal probability or normal distribution. So these two, I think, are nice to understand as a compare and contrast. So just kind of bear that in mind as we go through these last few lessons, that you do want to kind of look at these relative to each other. And there are what are called probability distributions. All right, so the scenario that I want to talk about is one that we might have found ourselves in as students. And so suppose that your teacher decides to give you a 4-question surprise multiple choice quiz, and it is a total shock to you. You had no idea this quiz was coming. You are not prepared. You did not do your homework last night. And so you get to class, and you can see here I didn't even include the questions, because sometimes that's how it feels when you're so ill-prepared for class. You read the question like, I don't even know what those words mean. So what do? Well, you end up doing what we would all do in this situation, which is just to guess. So I would like you right now to just write down what you would guess, right? If you had choices A, B, and C, 4 questions, what would your guesses be? So write down 1, 2, 3, 4. Write down what answer choices you would pick. Yeah, I actually want you to do this. Come on, commit in pencil. It's a big commitment, I know. Okay, so some of you probably have a strategy. Did you write down your answers? Write it down first before I talk. Okay, so some people have a strategy where they say, okay, I just commit to an answer and I stick with it. So I pick B for everything, maybe, something like that. And some of you maybe do the good old, like Christmas tree shape. Go out, come back, right? Have some sort of pattern, A, B, C, B, A, B, C, like back and forth, zigzag, right? So we have all these different strategies. Well, we might wonder about the math of this situation. At least that's what I would wonder about. I would wonder, as I handed my paper that I was ill prepared for, I might say, I wonder, what is the most likely score here? How many of the questions am I likely to have gotten correct based on guessing? I also might wonder, what's the probability that I'm going to pass? Right? It's a 4-question quiz. So in order to pass, like if I got 2 out of 4 right, that's 50%. That's not passing. But if I got 3 right or 4 right, whoo, that would be awesome. I wonder what the probability is that I passed. Might also wonder, get greedy, what's the probability of getting a perfect paper and really like fooling my teacher? Like it totally would look like I was ready for class today. And I also might really worry about the other extreme. What's the probability of getting all 4 wrong? Well, today we're going to learn the math behind all of that, okay? And it's something called binomial probability. So binomial probability has a very scary looking formula to it. My first year teaching, that is where I started. I started the lesson, I'm like, hey, let's look at this scary formula. And it was one of the worst teaching moments of my career, you guys. It was just a hot mess. And so what I've learned from that, what I took away from that is not to start there. Start with something people can understand. And we all understand the situation of being at school and having to take something that maybe we feel uncertain about. Okay? So to think about the math of that situation, we are going to think about the quiz we just thought about, right? It was a 4-question quiz. Let's look at it again. It was a 4-question quiz with 3 answer choices. Now, in order to have a binomial probability, right? That's what I told you the topic was. Bi means 2. And there are 3 answer choices. So that doesn't quite work out as it stands, right? A, B, and C, that's not going to be how we want to think of things. Furthermore, that's not how the teacher's going to think of things when this is graded. The teacher's going to think right and wrong. Oh, so those are the 2 outcomes. For any one question, I either got that one question right or I got that question wrong. And that's what we're going to put into our tree diagram. Okay, so this tree diagram is going to be kind of a lot, you guys. Okay, so have a big chunk of paper for yourself, okay? And really spread out at the beginning. So this set of branches, I'm going to spread out really wide. And I either got that right or I got it wrong. Okay, now some people do find it confusing to use R and W. You could use a plus and a 0 just as easily, like plus got it right, 0 got it wrong. That would be fine if you find the R and the W confusing. Okay, I'm personally going to stick with that, but I do know some people find that confusing. Okay, so that set of branches represents the first question. The second question, again, spread way out. The second question, I could get right or wrong. And then we'll continue on. The third question, you see why I told you to spread it way out, right? Because this is going to get really crunchy. And the fourth question. Okay, I'd like you to pause the video, finish your tree diagram by yourself. It's an important thing to have done. And when you finish your tree diagram, something else that I would like you to write off to the side is the sample space. So I'm not going to complete all this right now, but after you finish filling all of this in, you can see like the top path is getting 4 right. The next path underneath that is this one that I just highlighted in yellow, and that's 3 correct, number 4 is wrong. Okay, so finish your tree diagram, make a sample space list over here, and then start the video again, okay? Don't cheat, actually do it. It's a good process for you to know. You still didn't pause. Time to pause. Okay, so this is what you should have created. You should have your tree diagram written out. You can see I put in some extra horizontal lines just because my eyes are starting to go a little cross-eyed. And then in black pen off to the right, I have written out the sample space. So how many different patterns, how many elements are in the sample space? There are indeed 16. And if you think about it, it makes sense because the quiz had 4 questions, and every question either is correct or incorrect. So it's 2 outcomes, right? You either get a point or you don't. So 2 times 2 times 2 times 2 is 16, 2 to the 4th. Okay, and that's why there's 16 outcomes. So now let's look through our notes, and we'll continue to come back to this diagram as we look at these questions. So the number of questions that are correct is an example of what is called a random variable in X. In our problem, the random variable can take on the values 0, 1, 2, 3, or 4. So we said that the random variable was the number of questions that are correct, and we said that that variable could be 0, 1, 2, 3, or 4. So that is because on our quiz, which had 4 questions, right? Look like that. I could get none of these right, 1 of these right, 2 of them right, 3 of them right, or 4 of them right. There's no partial credit in a multiple choice situation, so it's not like I can get 3.5 points or something like that. So the reason that those are our outcomes is because those are the only possible number of points. Okay, so now we're going to look at this list, and we're going to look back at our tree diagram. So if you have a tree diagram on a piece of paper in front of you, that would be the best. Okay, so look back at your tree diagram, and the first question is how many branches represent the score of 0, the random variable equaling 0. So I'm going to move this out of my way. All right, so 0 means I got 0 correct. Fortunately, for students everywhere, there is only one situation where that happens. That's this one right here. I get all 4 wrong. So there is one branch that has a score of 0, excuse me. A score of 1 means I have 1 right. So that's this one, and this one, this one. Is there anyone else? This guy. Okay, so those 4, there's 4 ways to have a score of 1. Okay, I'm going to go to the other extreme now rather than going in order. How many papers have a score of 4? Well, that would just be this one, right? 4 right. There's no other way to get a score of 4, so this is 1. Let's see how many had a score of 3. 3 correct. That's 3, 3, 3, here, 3. That's it. Okay, so remember that there were 16 total branches. Here's 5, here's another 5, so that's 10. So that must mean the other 6 branches all have a score of 2. 2 right, 2 right, 2 right. Yeah, that's right. Okay, good. So 1, 4, 6, 4, 1. These numbers show up in something that is called Pascal's triangle. You might have seen it before, you might not have. But Pascal's triangle starts out with this group of ones, and then every subsequent line has ones on the edge, but the middle numbers are found by adding these two together. So the next line would have ones on the edge, and then here 1 plus 2 is 3, 2 plus 1 is 3. The next row would have a 1 on the edge and a 1 on the edge, and you add together the numbers. So 1 and 3 make 4, 3 and 3 make 6, 3 and 1 make 4. These are the numbers that showed up in this problem. And those numbers from Pascal's triangle actually are also combination numbers. So if I were to have 4 choose 0, that's 1. 4C1 is 4. So these are the numbers like when we talked about combinations. Is that last lesson? The videos are starting to blur together to me, you guys. Yeah, I think it was last lesson. When we talked about combinations and permutations, these are the combination numbers that go with 4 things. And if you think about it, this makes sense because how many quiz questions did we have? 4, right? How many ways were there to get 4 correct? There was 1. If I have 4 questions, how many ways were there to get 3 correct? There was 4. If I have 4 questions, how many ways were there to get 2 correct? There was 6. So these numbers that happen to be in this thing called Pascal's triangle are also our combination numbers, are also the numbers of how many different branches are associated with each score. Okay? Now I need you to set that aside in your head. Just kind of put that aside for a minute. We're going to explore something else, and then we're going to weave those two things together. Okay? Here's the something else. Okay, I have a series of questions for you. What is the probability that you answer one of the individual questions in the quiz correctly by guessing? So let's go back to what that quiz paper looked like. What is the probability that I got question 1 correct? I don't know what the right answer is, but it's either A or B or C, right? One of those is correct. One of them is correct out of how many? Out of 3 choices. So my probability of getting that first question right, or any one question, is 1/3. 1 in the 3 answer choices is correct. So the next question is a follow-up. So what is the probability that you answer a question in the quiz incorrectly when you randomly guess? Well, if the probability of getting it right is 1/3, the probability of getting it wrong is 2/3. 2 out of the 3 answer choices are incorrect answers. The next question is, are answering the 4 questions of the quiz independent? Here we are going to say yes. Answering A for question 1 doesn't need to have any bearing on question 2. It's not like if you answer A on 1, now you can't answer A on number 2, right? There's no necessary impact. You can make each of those 4 decisions independent of one another. And the last question is one of these fake questions that teachers sometimes ask. Can you find the probability for each of the branches in the tree diagram? Yes, of course. That's what we're here to do today. So let's do that. Okay? I'm actually going to start not with this first one. I'm going to start here. I feel like this case is a little bit special and therefore confusing. So let's start with this one. Let's find the probability of answering one question right. Exactly one question right. That's what that means. What is the probability that my score is 1? Well, if I go back to my notes here, there's 4 different paths that lead to getting a 1. So I'm going to start out with the number 4. Actually, I'm going to put that underneath. Sorry, let me think ahead about this. Okay. So we have a 4. And then in answering one question right, that means this 1/3 probability happened one time. If I got one question right, I also got 2 questions wrong. So I have 2/3 times 2/3, or 2/3 twice. I have 1/3 once, and there's 4 different ways for that to happen. The 4, as we discussed, is actually because of 4 choose 1. Right? Out of the 4 questions, I could choose any one of them to get right, and I would have a score of 1. Okay, you can see this more clearly back in the tree diagram. Let's pick one of the options where I had a score of 1. Let's say it was this guy. Okay, that is this path. So back in my tree diagram, if I had put the probabilities in, this branch has a probability of 1/3. And these branches have the probability of 2/3. Oh, you know what? I made a mistake in this, didn't I? Oh gosh, I'm sorry guys. I should probably go back and re-record, but I'm not going to. I was thinking about having 3 questions. We had 4 questions. Was that confusing you? Good job if it was confusing you. Sorry. Okay, so let me reiterate why that had to be a 3. I was just being foolish. Okay, it's a 4-question quiz, remember? I'm mostly saying that to myself because I didn't. Okay, so here's our 4-question quiz. If I get one of these right, like this problem right, then I got these 3 wrong. That's why this has to be a 3. I was just confused. Okay, so that's our setup. We could plug that into our calculator, we'd get an answer. Okay, let's go back up here and set up this one. Okay, so my probability of getting 0 correct. Out of the 4 questions, I want to get 0 right. If I get 0 right, that 1/3 is not going to show up at all, but 2/3 is going to show up 4 times. Let's look back at the tree diagram. Okay, so getting a score of 0 happens way down here. Sorry, trying to get a highlighter, but maybe that's not going to be the case. Here we go. Okay, so my score of 0 was this. And what is the probability of getting a question wrong? 2 out of 3. And for each of these W's along the way, there's another 2 out of 3. So I have the probability 2 out of 3 4 times. I didn't see the probability 1 out of 3 at all. Okay, so that's my setup. Now, if you look at the purple writing and the blue writing, and you kind of just don't even think about the math per se anymore, I think you can see a pattern, right? They both start out with 4C something. So 4 choose, what will this number be for this problem? So 2, right? Because this 0 meant there was a 0 here. This one meant there was a 1 here. So this 2 means there's a 2 here. And then I'm going to have a 1/3 and a 2/3. This was the probability of getting the question correct. This was of getting it incorrect or wrong. And then this question was asking the probability of getting 2 right. If I get 2 right on a 4-question quiz, then I got 2 wrong. So now look for more pattern. This 0 was here and here. These 2 numbers, they always add up to 4, right? And then the numbers that are in the parentheses are success, the probability of success and probability of failure. That's the pattern, okay? So it's pausing time. I'd like you to pause the video and I'd like you to set up the last 2. Go for it. Okay, this is how you should have set up the last 2. So we have 4C3, 1/3 to the 3, 2/3 to the 1. You can see my decimal answer for both of those. And so my next question to you is, where do the number of branches come into the setup? The number of branches for each score is that first number, right? This guy right here, this is 1, this is 4, right? That's where the number of branches is in the problem. And then the next question I have for you is, what do all the probabilities add up to? Well, they should add up to 1. But I was too lazy back here to get out my calculator. So let's look at how you can do this on your calculator in 2 different ways. One way would be to type it in just how it looks. So I can go here to my calculator, and I could just go right ahead and type what it said there. So I can go into math, over to probability, pick up my combination, say 4C0 times, oops, not there, times 1/3. And I'm not even like, I know you guys are probably saying, oh, but you this or that. I'm just literally typing what's on the page. Okay. I know there's probably some things I don't fully have to type here. Okay. So like that, and just get my answer. But there's another thing. Okay. There's another way that's built into your calculator. That's really nice, I think. So we're going to look for the distribution menu. So that's second, and then on the variables key, right over here, it's in red right now on my screen. There's a baked in binomial distribution. It's down here a bit. Here it is. So binomial probability distribution function. It's easy to remember because it's PDF, like making a PDF file on your computer. So binomial PDF. So then we would say, okay, I have 4 trials because there are 4 questions. My probability of success was 1/3. And I'm currently finding out, I was working on the value of x equals 0, and that was 19%. Let's do 1 now. And come down here. Okay, it'll look like that. And that's 39.5. So I'm going to go back and write those two down. 19.75. And this was like 39.5 or something like that, right? And then you could do this one either way. So whichever way you prefer. I kind of like that last way. And look at this. This is like really even easier. If you do second entry, you'll get that back. And I don't have to even type in anything else. I'm just going to change that to a 2 now. And that'll give me the answer for the last one. So 29.6. 29.6%. Okay, so those 3 blue numbers plus these 2 numbers in black should total 1 because I've done all of the outcomes. I've covered the entire sample space. And that's how you do binomial probability. Now we can answer all those questions that we had at the beginning. How many of the 4 questions are you likely to have answered correctly? Well, which of these is the biggest probability? This one. Too bad. The most likely outcome is getting 1 right. The most likely outcome, if I guess on this quiz, is getting a 1 out of 4. What is the probability of passing, right? Getting more than half was passing. We add these together. That's what our answer would be. It's like 10, maybe a little bit more like 11.1%. I just estimated there. I didn't actually add. Okay, so I hope that's in the ballpark, okay? You just add these 2 together. That's not very good. 11% chance? Yee. What is the probability of getting all 4 right? Well, that was right here. 1.2%. That's horrible. And what is the probability of getting all 4 wrong? Ooh, that's kind of a significant probability. Almost 20%. Why are these so different? They're both extremes, right? They each had 1 branch on the tree diagram, but they don't have the same probability. Do you know the answer? You're right, it's because you had 3 answer choices. Getting it wrong is twice as likely as getting it right. That really makes, so if I had answer choice D, would the change between these be even more extreme? You bet. That is why teachers will put 4 or 5 answer choices. It makes multiple choice much harder to get correct. Okay, so you actually already used the scary formula, but let's first talk about how you know if you should use the scary formula. So there's this few criteria we look for. A story problem is a binomial problem if there's a fixed number of trials. So in this problem, the fixed number of trials was 4. The teacher wasn't like, oh, I'll just ask you as many questions as I feel like at the time or until the clock runs out and you guys have to go to your next class. It wasn't like that. It was, these are 4 questions. You are doing the 4 questions. That's a fixed number of trials. The trials are independent. You could pick an answer for each one. One had no bearing on the other necessarily. You could put things into 2 categories. So even though there were 3 answer choices, we could group them into correct and incorrect. So as long as you have like a success, quote unquote, category and a failure, quote unquote, category, then you have 2 categories. And the probability has to be the same for each trial. So if in this story I had those 4 questions, but this one was true, false, and this one was answer choices A through D, and then this it would have answer choices A, B, and C like that, then this would not be binomial. You could figure out probabilities, but it just wouldn't be binomial. It'd be a different thing. Okay, here's the scary formula. You already used it. This is the combination number that you put in the front. P is the probability of success. 1 minus P is the opposite probability. So if P were 1/4, then 1 minus P would be 3/4. If P was 1/5, then 1 minus P would be 4/5, right? It's like the opposite probability, the complementary probability. And then this number matches this number, matches this number, always. And these 2 numbers have to add up to your total, however many trials you were having. And that's the scary formula. The scary formula lives in your calculator right here for binomial PDF. Okay, so honestly, if you have your calculator, you don't really need to know the formula. You just need to know how to plug it in. Okay, so that's the scoop with binomial probability. Do you remember at the beginning I asked you to write down your answer choices? Okay, so if we were in class, I would tell you my answer key. This is my answer key. I wrote it down in advance. I'm not trying to like do anything in particular. I'd like you to tell me on the Quizlet or the little like quiz thing in today's folder, how many you got right. So did you get 0 right, 1 right, 2 right, 3 right, 4 right? Because I save everything. This was an example from my class first semester, 7%, 73%, and so on. These percentages are different than the percentages that we found because these would be experimental. Experimental probabilities or experimental results, okay? The theoretical results are what we did in class, right? We just did our theoretical results back here were these numbers in blue and the numbers in black. So I just thought it'd be fun if today you tell me how you did on our fake quiz. This is the answer key, score yourself. Number 1 is C, number 2 is A, number 3 is B, number 4 is A. And then in the response form for today, tell me how many you got right. And I will tell your class then how close our experimental results were to the theoretical. Thank you so much. Okay, here's our answer key again. I will publish this later on with our group's results. We'll see how close we get to the theoretical. Thanks so much. I know it was a long lesson. I appreciate your attention.